In this set of notes, we tie together two concepts that we have already seen. The first of those is the fundamental theorem of calculus. If we can take a function's antiderivatives, we can compute its definite integral. The second is U substitution. We learned U substitution as a technique for computing indefinite integrals. So now we'll ask, how can we use U substitution and the fundamental theorem of calculus to compute definite integrals? In this video and the corresponding set of notes, we'll merely introduce the kind of problem we're trying to solve. Suppose we are trying to integrate from 0 to pi 3x squared times the sine of x cubed dx. And for a moment, let's ignore these limits of integration and look at a corresponding indefinite integral. This is a classic case for U substitution. Remember that you use U substitution when you have composition, and the derivative of this inside function appears inside your integral. Then you let U be the inside function and convert everything into U's. And now let's go back to our actual problem. Suppose we have limits of integration here. The question we're trying to resolve is, what goes here? It would be incorrect to write to 0 and pi there, because 0 and pi are x values. Everything here is in terms of x. Our expression is in terms of x. We're integrating in terms of x. And x is going from 0 to pi. Here, everything's in terms of U. The sine of U, we're integrating with respect to U. And if we wrote 0 and pi here, it's U that's going from 0 to pi. But just because x is doing this doesn't mean this dummy variable U should be. So whatever we write here, it surely shouldn't be that. There are two ways to finish out this problem, essentially. And having laid out here the question, as it were, we'll lay out the answer in the next video.